Tēnā koutou katoa, called Jeremy Ahau. Now recently I was on Reddit and I posted up some pictures that had been taken by my GMN meteor camera, and I mentioned that I had got 0 Perseids recorded over the last few nights, last 4 clear nights. Mentioned this on Reddit. I posted up the images from the nights and some plots, and I had this comment here. Somebody asking, those graphs are interesting, will you explain the graphs, like what are they called and what they show and what do you mean by 0 Perseids? So I thought I would throw this video together as a brief explainer. And what I mean by 0 Perseids is that my meteor camera did not record any Perseids, and that's a little bit surprising perhaps for many people, because Perseids are all online at the moment, people wanting to go out and see how can I watch the Perseid meteor shower, where's the best place, when does it peak, when does it, all these sorts of types of things. And so people are expecting lots of meteors, lots of Perseid meteors to be seen at the moment. And my point really is that my meteor camera is not seeing any Perseid meteors. It's seeing other meteors, but it's not seeing Perseids. So let's go into a little bit of detail about what we're talking about here. What I have is this meteor camera on the side of my house. It is a global meteor network meteor camera. It is essentially a security camera in a box pointed up at the sky, and it has a little Raspberry Pi which is continually monitoring all of the images that come off. So that meteor camera on the side of my house is pointing approximately south, and it's getting a view over the South Island of meteors flying through the sky over the South Island of New Zealand. Now what I can do is I can get a look at the results, the things that are actually coming up on the system, and in a bit of a dashboard that the Global Meteor Network provides. So here, for instance, is a list of all of the captured thumbnails over the course of an evening. And you can see it starts out with white thumbnails because it's capturing in the early dusk, and then as night falls it starts being able to see what's in the sky. And as you scroll down, you can see each exposure is captured of the sky for a period of time, and it's just taking a picture of the sky and has all of the information, all of the things that you actually would see in the sky in that particular moment in time. It's carefully exposed so that it brings out as much detail as possible. You can see the various white streaks that are appearing through here. Some of these are meteors, some of them are planes, some of them are satellites, and all of this information is captured every few seconds over the course of a night. You can see a few clouds that came in around midnight, and but it was a reasonably clear night. There was lots of clear sky, and then dawn came and the images got washed out. Okay, so it takes all of these images and it processes them. These particular images here are a subset. These are the ones where meteors were actually detected out of all of the images that were taken through the night. These particular ones, the software detected as meteors. All of the frames have been stacked together like this, and you can see all of these streaks. Some of the circular streaks are stars, or these circular streaks are stars as the sky has rotated, and the stars have traced out their path through the sky. Those have been captured, and all of the stars show up as circular streaks. All of these other lines and things through here, a lot of these are planes. You can see the alternating strobing on each side. These are all planes coming through here like this. The software goes through and eliminates a lot of this sort of type of noise, and it creates this stack here, which is a sum of all of the images through the night with all of the nonsense erased. It's got all the stars basically erased, and it's got all of the planes removed, and you're left with the view of the night sky, the camera view, and all of the meteors that streaked through that particular view. So these are all in the perspective of the camera itself. They're not necessarily in the same position in the sky, because of course the sky rotated through the night. You can just see the faint traces where the stars have been removed, these faint circular traces. So what we can say is that within a particular view of the camera, it was able to see these meteors, and it knows which particular time these meteors happened, and therefore which part of the sky they went, because of the timestamps of those images. So it goes and processes all of this information, and it creates a sky map like this one, which is the one that you're asking about. This chart is a geocentric ecliptic coordinate chart, and what it is showing is where the radiance of the detected meteors come from. What the software has been able to do is it's been able to identify the path of the meteor and has been able to trace that path back to where its original orbit, and from there it's been able to sort of like see which part of the sky the meteor was coming from. Now, meteors coming from a particular location are given a particular name, because if there are a whole bunch of meteors coming from that location, it's called a radiant, and that is because the source of all of those meteors is the same thing, usually a trail left by a comet or something like this. Is basically the dust and litter left behind in the trail of a comet. When the Earth passes through that trail of the comet, all of the material of that comet seems to be coming from a same particular point in the sky. And the Perseids are a set of meteors that appear to be coming from Perseus, and hence the name Perseids. Now, this particular chart plots where in the sky you're seeing these come from. Now, this is a little bit like a Mercator projection map of the world. It's distorted. It's not the sort of type of map that you would imagine. This is not a globe. This is being distorted and stretched, but it is actually representing the entire globe around us, all of the coordinates. From our perspective, it's geocentric, with the ecliptic being a lot through the middle. So when you trace the origin of the meteors back to a particular part of the sky, you can see particular regions of where those meteors are coming from. And in this particular plot, you can see 4 of them have been circled. They're labelled Erie, Pau, SDA and NDA. The radiant labelled Erie are the Eta Eridanids, the NDAs are the northern Delta Aquariids, the SDAs are the southern Delta Aquariids, and the PAU is the Pisces Austrinids. So you can see a few other streaks on this map, which are other meteors that have been detected by the camera, but they haven't been given a particular radiant identification. They haven't been able to identify which particular radiant these belong to. But you can see that this line here, for instance, this was a meteor that was detected, and the line has been traced back up this way, and it goes back up to the southern Delta Aquariids radiant location. Now, the reason why that line is bent is because this map is distorted, because it has been a globe that has been stretched so that we can see it. The same, a little bit like we see with a Mercator projection map. It's been stretched and distorted for the purposes of representation. So straight paths on this map show up as curved. So just like great circle paths that a plane flies over the globe show up as curved lines on a Mercator projection map. I will say that this geocentric ecliptic coordinate projection here is representative of my camera's view. When all of the camera's views are summed together, a different projection is seen. So for instance, this projection here are yesterday's Global Meteor Network radiant plots for all of the cameras around the world, and you can see different radiants showing up here as bright spots. These are the Perseids that are showing up brightly here. The count is high for this particular shower. There's other ones down here, like the Eta Eridanids, like one of the ones that I captured on my camera, but I wasn't capturing any of these particular ones. You can see that this coordinate system is different from the coordinates that were on mine. They're plotted differently along the chart here. You can see 0 is here, and this is the sun-centered geocentric ecliptic coordinates, and here 0 is towards the sun. And you can see that's the reason why there are lots of meteors detected over here on the dark side away from the sun, but very few. There's only around the edges around here, not so much around here towards the sun. So we haven't captured and been able to plot many in this direction because we're looking into the sun here. There's the anti-solar point around here, this distance further away from the sun, and you can actually see there's different speeds plotted on here. The fastest ones are right in the middle of the plot in the more yellow colours. Those are the ones travelling fastest because the Earth is ploughing straight into them. The cool blue ones that are plotted over here, I'll just move the mouse so that you can see them, it turns back to blue. Those are meteors that are coming in from behind the Earth, so they are relatively slower. So you can see here the solar point and the anti-solar point plotted on the sun-centered geocentric ecliptic coordinates. But this is the sum of all of the meteor camera detections across the globe from all different sources. Let me go back to this plot here showing my camera. Down the bottom you can see a plot of the months, and various stripes along here represent the periods that you can see certain meteor showers. So the Perseid meteor shower is represented here in this blue stripe, and the plus is around about where the peak is. That indicates that we're around about the peak of the Perseids, but despite this being around the peak of the Perseids, on this particular camera here in the top of the South Island of New Zealand, we are seeing some of the meteors from other radiants, not from the Perseids, at least over the last 4 nights. You can see in the legend up here at the top, it says that there were 9 Eta Eridanids, there were 8 Southern Delta Aquariids, there were 5 Northern Delta Aquariids, and there were 2 Perseids Austronauts. So there you go, there is an explanation of the photos that I put up on Reddit, along with an explanation of the associated plot that charted where these meteors had originated from, where their radiant was. If you would like to know more about these global meteor network cameras and how you can install one yourself or create one from some security camera parts, cheap little modules that you can purchase from AliExpress, and a Raspberry Pi, you can check out globalmeteornetwork.org online.